Okay, in this video, we're going to learn about function basics, and we're going to start with the definition of a function. So a function is where for every input, there is exactly one output. Okay, and another way of saying this is for every x, there's exactly one y. Okay? So let's go through what this looks like on a table and an equation and on a graph. So for a table, really what this means is that x should only appear once, because when I have an x, I should only have one corresponding y for that x. So in this example, every x is different and every x goes to a y value. Now notice that the y values could repeat. That's okay, as long as our x's are not repeating. So every x only goes to one value for y in each of those. Now in the non-example, we have a case where we have x of 5, but x is going to two different y values, right? We have 5 going to 2 and 5 going to 4. This is where it's not a function, because every input needs exactly one output. And in this case, my input has two different outputs. So this was what makes that not a function. Another way of thinking about this is that x cannot repeat. Okay. Okay. All right, so in the next one, we have an equation this time. The biggest thing that you want to look for in equations is you want to make sure that y is to an odd power. And the reason for that is when I plug in a number to my equation here, I get y equals, and I'm just going to get one answer, right? Because y is already by itself. Versus my non-example, when I have y squared, if I want to get y by itself, I'm going to have to square root both sides. And when you square root an even power, when you root an even power, you end up getting plus or minus that answer, okay? Which means that we get two outputs. So when you have y's to an even power, that is not going to be a function. So y can't be to an even power. Okay, that's the easy way to tell with equations. And then lastly, we've got graphs. So for graphs, the easiest way to tell is by doing a vertical line test. So we can write that in, vertical line test. And the vertical line test says that if you draw a vertical line anywhere on the graph, it should only go through the function once. Because if I have an input of -2, for example, so I draw a vertical line at -2, it should only touch the graph once, which it does. Same thing here, same thing here. It's only ever touching the graph once. Versus the bottom one, if you draw a vertical line at 0, you're hitting the function at both positive and -3. So there's two outputs. So this would not be a function. Okay, so not a function. All right, moving on. So for function notation, the reason we use functions is because functions are more informative. So we would write this as f of x equals, and then you write your equation there, or your expression there, f of x equals y. So what this does is if I have f of 2 equals 3, this now tells me when x equals 2, y equals 3, without having to write out a whole sentence, okay? So it's more informative. So function notation uses f of x, okay? You could also use h of x or g of x or anything like that, but anything of x, g of x, you could do h of t, okay? But whatever number or whatever variable is inside of the parentheses, that represents your input, okay? And then when you evaluate it, that's your output. Okay. So let's look at some examples. So we've got f of x is given by the equation, negative 3x squared minus 5. G of x is given by the graph, and h of x is given by this table. And we want to evaluate all of these different functions. So let's start with A. We're first starting with f of 2. So f of 2 means I'm going to plug into for x into this expression right here. So I have negative 3, 2 squared minus 5, okay? That's f of 2 times g of 1. G is given by the graph, so they're asking what is our y value when x equals 1. So we're going to look over here at our graph. Right here is when x is 1. So I'm following that down to the function and reading off the value, which is negative 2. So g of 1 is negative 2. And then we're just going to evaluate our function by using order of operations. So we've got negative 3 times 4 minus 5, all times negative 2, negative 12 minus 5, times negative 2, negative 17, times negative 2, and then this equals positive 34. And that's it. All right, let's try these other ones. So we have h of 4 minus g of 2. H was our table. So h of 4 is saying again when x equals 4, what is y? So when x is 4, y is 14. Minus g of 2. We're going to follow 2 on this graph, and it looks like it's at 1. So 14 minus 1 is 13. Okay? All right, moving on. So 3 times g of 0. So 3 times g is our graph. So g of 0, we're going to look where x is 0, y is negative 3. Plus, and then f of g of 2. So the first thing I'm going to do is figure out what g of 2 is. So we already found g of 2 over here. G of 2 equaled 1. So I'm replacing g of 2 with 1. Okay? So simplifying, 3 times negative 3 is negative 9 plus, now we're doing f of 1. So I'm going to plug 1 into my equation for f. So negative 3 times 1 squared minus 5. 9 plus, that would just be negative 3 minus 5. So negative 8. And we get negative 17. Okay? And then our last one, we have f of x plus 1. So now we're just plugging in a binomial for x. So negative 3 in place of x, I'm putting x plus 1. And then I'm going to simplify all of this. So we're going to FOIL out x plus 1 squared plus 2x plus 1. And then distribute your negative 3. And simplify. And that's it. So all of this should be a quick little review, but it's all about simplifying functions. All right, so in this video, we learned the definition of a function, how to determine if a table graph equation represents a function, and how to evaluate a function by either plugging into an equation, looking at a graph, or reading a table. Thanks for watching.